Hey guys, and welcome back to my channel. So we are going to now talk about slant asymptotes. So that's going to be today's lesson. So first, I just want you guys to look on page 11, the bottom of the page. Okay, it says consider the function g of x, which is x squared minus x over x plus 1. And I ask, what is the horizontal asymptote? Okay, well, because this is top heavy, we know that there is none. So because this is top heavy, we know that there is no horizontal asymptote. And if you remember what I said from class, if there's no horizontal asymptote, well, what does that mean that exists then? Good. That means that there would be a slant asymptote. So that's what we're going to be focusing on today. So all of the functions that we look at, for the most part, all of those will be top heavy. All right, so let's flip to the next page and take a look. All right, so you'll see on the next page here, I have for you that a slant asymptote, again, that's going to occur when the polynomial in the numerator has a higher degree than that of the polynomial in the denominator. Okay, so in order for us to find slant asymptotes, what we are going to do is perform long division or synthetic division on the rational function. So if we look at exercise 1 there, this is top heavy, meaning that there will be no horizontal asymptote. So since there is no horizontal asymptote, we know a slant asymptote exists, and we now need to find it. And here's how we're going to do it. We're simply going to do long division or synthetic division on the two polynomials. So I'm going to go with synthetic division, since that is easier to work with. So when x is equal to negative 3, okay, so x is negative 3, I'm just going to perform long division on this. So we'll bring down the 1. Same rules apply, everything that you guys have learned about synthetic division. Negative 3 times 1 is negative 3. I'll have minus 9. And then negative 3 times negative 9 is positive 27. And I'll have a remainder of 26. And now you're probably thinking, well, what do I do with this remainder? And actually, we ignore it. We don't use the remainder. Now, what this is going to look like is the equation y equals x minus 9. So that's where your slant asymptote is going to exist. If this ended up working out, that there was no remainder, well, then it wouldn't be possible for a slant asymptote to exist. Okay, so I'll say that again. You want there to be a remainder if a slant asymptote exists. If there was no remainder, then there wouldn't be a slant asymptote there. Okay, so all I care about is the 1 and the negative 9, which helps me come up with my equation here. All right, let's look at another example. So let's look at question number 2. Again, this is going to be top heavy, so we know that there's no horizontal asymptote and that a slant asymptote exists. And again, we're going to do long division on this or synthetic. So since I did synthetic division here, I'm going to do long division for my second example. All right, so I have 3x minus 6 is getting divided into this x squared plus 6x minus 4. Just to walk through the steps on long division. Okay, you can fast forward through this if you already know how to do this, or you can pause the video and do this yourself. So I have, how many times does 3x go into x squared? Well, you have to think. 3x times what will get me to x squared? So 3x times what will get me to x squared? This would have to be 1/3 x. So that's going to bring me to 1/3 x up here. And I'm going to distribute that back, which will be x squared minus 2x. So I'm just distributing this here and here to get these terms here. Okay, let's continue. We'll just subtract this out. You'll be left with, let's see, 8x minus 4. And again, we're going to do long division on this one more time. So we have to think now. 3x times what will get me to 8x? That would be 8/3. So that's going to go right here. And again, if I redistribute this, again, there should be a remainder. If there isn't a remainder, then a slant asymptote doesn't exist. So let's go through this. When I redistribute this back to each term, I'll be left with 8x minus 16. And I will have a remainder of 12, and that's fine. Okay? So, what is my final equation? Here is my final equation right here. So that would be the equation for the slant asymptote for this example. I'm just going to rewrite this as y equals 1/3 x plus 8/3. All right, so that's my slant asymptote for number 2. Why don't you guys try number 3 and then we're going to move on. So I would pause the video here and give number 3 a try. All right, so for number 3, hopefully you got y equals x plus 7. Again, you can take a look at the work up here. I just performed synthetic division on my 2 polynomials. All right, let's move on to the next page, which is page 13. All right, so I'm going to look at letter A, and I'm also going to do letter B with you as well. So let's look at letter A. So to find the vertical asymptote, again, you have to recall that we set that denominator equal to 0. So when that denominator is set equal to 0, my x value is going to equal 1. Again, make sure you are including the x and y values. Okay, I need to know x equals or y equals. All right, next we need to check out if there's a horizontal asymptote, and if it exists, what is it? So this is top heavy. And again, if you recall, when I have a top heavy rational function, that means there is no horizontal asymptote, meaning there is a slant asymptote. So again, to find that slant asymptote, well, I know x minus 1, x would be 1 when we're doing long division on this. We're taking that factor. So when x is 1, I have 1, -1, and -2. And I'm just merely going to do synthetic division. And here is what we are left with. So this would just be y equals x. That's my equation for the slant asymptote. So I'm going to sketch that on my graph. And I'm going to also sketch out the vertical asymptote. So I'll color code them for you. All right, so this is what we have so far. So I sketched my slant asymptote and my vertical asymptote. Now we need to take a look at the x and y intercepts. So now if you recall, to find the x-intercept, that's when y equals what? 0. So when y equals 0, and now again, this recalls us to understand what it means for a function to wipe out to 0. So when y equals 0, that's when the numerator will equal 0. So I'm going to factor the numerator, because once that numerator goes to 0, that's when y will equal 0. So if I factor this out, I'll have x minus 2 and x plus 1. When I solve for x, I'll get x to equal 2 and then x to equal -1. So those are my x-intercepts. So I'm going to write that here. We have 2, 0, and -1, 0. And I'm going to draw those in on my graph. I'll indicate that with a red point. Okay, so there are my 2 x-intercepts at 2, 0 and -1, 0. Now we need to find out what the y-intercept is. And now again, that's when x equals 0. So when x equals 0, well, you actually need to go back and check out what happens when x equals 0 to this function. So if x equals 0, well, this will be 0, and that will be 0. So I'm left with a -2 in the numerator. In the denominator, when x is 0, I'll be left with a -1 in the denominator. So -2 over -1, that is just +2. So y will equal 2. So that gives me the point of 0, 2. And I'll also sketch that as well on the graph. Okay, so I have all of my key points. Now we need to partition the x-axis. So again, that pertains to the x-intercept as well as the vertical asymptote. So we are going to now partition the x-axis, and let's see what happens. So when I partition the x-axis, so you guys can do the math on your own here, but I just plugged back in to my factored polynomial. So really what I looked at was the x minus 2 over x plus 1, plus 1, all over the x minus 1. So for instance, if I picked when x is 0, so that would fall in here. When x is 0, well, 0 minus 2 is negative, 0 plus 1 is positive, A negative times a positive is a negative. And then 0 minus 1 is negative. A negative over a negative is a positive, which is why this was positive. Okay, so again, you can check out the math on your own. So if you want to pause the video here and make sure you get to those same conclusions. All right, so what we're going to do next is now we're actually going to graph this and what this actually looks like. So as I come from negative infinity to -1, all of my values are negative, and we're going to be bounded by this slant asymptote. So all my values here are negative. Okay, as I go from -1 to 1, so that's along this vertical asymptote. So as I go from -1 to 1, all of my values are positive, and I have to connect back to my y-intercept. So there's part of the graph. Now we have to come up with the other piece of the graph. As I go from 1 to 2, so that's really between here, really between here and here, I need to see what happens to the graph. Well, it's going to be negative. So all of my values between 1 to 2 are negative. And then as soon as I intersect on the x-axis, when x is 2, all my values afterwards become positive. Okay, so that's what our graph is going to look like for letter A. Again, you can go back and rewind any questions you may have from this question. And I'm going to move right along to our next example. So let's take a look at letter B. All right, so for letter B, what we first want to do is take a look at what the vertical asymptotes are. Now, you always should be looking to factor as much as you possibly can in the numerator and denominator. So if I factor out this denominator, what I'll be looking at is 2 times x squared minus 4. And we can factor that even further, because this is dots. I'll have 2 times x minus 2, and then x plus 2. That's all in my denominator. So I'm just going to rewrite this to clean this up. All right, so now that I cleaned that up, let's take a look at what those vertical asymptotes are. So when we set that denominator equal to 0, we'll have a vertical asymptote at x equals 2 and x equals -2. So I'm going to start by sketching that in on my graph. And I'll do that in red. All right, and I'm going to also label. I want you guys labeling the vertical and horizontal asymptotes. Okay, so now we got to take a look to see what the horizontal asymptote is. So the horizontal asymptote, well, let's check this out. This is top heavy. So since this is top heavy, what do we know then about the horizontal asymptote? Exactly. There is none. Okay, so that means there's going to be a slant asymptote. And I'll do that now in blue. All right, so again, in order for us to find the slant asymptote, what I'm going to do here is now long division. I can't do synthetic division on this because this has a squared in it. This is not a linear factor. So we're going to have to do long division. So if I do long division, I have 2x squared minus 8, which is getting divided into x cubed plus 0x squared plus 0x plus 0. All those placeholders. All right, well, this one's actually going to be quick and easy, and you guys are going to see why. When I divide x cubed by x squared, you should have an x somewhere remaining. So we're going to be able to stop once we get to a term with just an x. So I'll repeat that one more time. X cubed divided by x squared, there's going to be an x remaining when I divide those. So we're going to be done once we get an x value attached to our long division because the rest is the remainder, and we don't care about the remainder. All right, so let's check. 2x squared times what will get me to x cubed? So 2x squared times what will get me to x cubed? Well, we need an x. So 2 times 1/2 is going to be 1. So there you go. 1/2 x. Okay, and let's just double check our math here just to make sure. All right, so I just kind of went through and finished with the long division. So as you can see, there are no significant terms after that 1/2 x. I don't care about 2 over x. That's just part of the remainder. Because again, as I said before, x cubed over an x squared, you're just going to be left with an x in your answer. Okay, so really, this is all I care about, is this 1/2 x. The rest of this is just irrelevant. Okay, so my slant asymptote is going to be at y equals 1/2 x. And I'm going to graph that in blue on my graph. All right, next we have to figure out what the x-intercept is and y-intercept is. So this is actually going to be pretty quick. So the x-intercept, again, that's when the numerator is equal to 0. So if I set the numerator equal to 0, well, that means x is going to equal 0. So my x-intercept is at 0, 0. And I'll say that again. Numerator we set equal to 0 because y has to equal 0, and I'm solving for that x value. Well, the only value for x that's going to make this go to 0 is 0. Similarly for the y-intercept, okay, so for the y-intercept, we set every x value to 0. So if I set every x value to 0, let's see what happens. This will become a 0. This will become 0, minus 8. Well, what's 0 over negative 8? That's still just 0. So I'm going to graph that point right on that slant asymptote. Okay, similar to horizontal asymptotes, slant asymptotes, again, really model just the end behavior. So you can cross over a slant asymptote. It's just the vertical asymptotes you can never cross. So you can cross a horizontal and you can cross a slant asymptote, but you cannot cross over a vertical asymptote. Slant asymptotes and horizontal asymptotes are testing the end behavior, not what's in the middle of the graph, but what's happening on the ends of the graph. Okay, so let's actually start to graph this now. Well, before we can actually graph this, we need to partition the x-axis. And how we partition the x-axis is by, again, coming up with that number line. So when I come up with that number line, we want the vertical asymptotes and the x-intercept. So I have -2, 0, and 2. So here's where I would probably pause the video, and I want you guys to check out positives versus negatives between each interval. Okay. So what you should have gotten is negative, positive, negative, and positive. Okay, so now let's actually understand what this means on the graph. I'm going to graph this in black. Okay, so as I go from negative infinity towards -2, so I'm going from negative infinity to -2, that direction. All my values are negative. Well, I can't be above the asymptote because I can't cross over. Okay, so I can't cross over because this is dealing with the end behavior, dealing with what's happening on either end. So I'm going to start below the asymptote, the slant, and I'm just going to continue my graph. Okay, so again, these are all the values where this is negative. Now as I go from -2 to 0, so I'm going to be in between this region, all the values there are positive. So positive is above the x-axis, and I have to intersect my x and y-intercept. If I look as I go from 0 to 2, all of my values are negative. Okay, so again, ooh, that looks bad. I'm going to tend towards that vertical asymptote. I can cross over the slant because what's happening in the middle is not the end behavior. Okay, and as I go from 2 towards infinity, all my values are positive, so I have to be above the x-axis. Okay, and there you have it. So I went through 2 examples. If you find you're still having some difficulty with this, you can keep watching and I'll go through one more. All right, so I'm going to go over letter F on page 15. Again, if you are good with this, those 2 examples made sense, then you don't need to continue watching. All right, so first things first, we need to find the vertical asymptote. But now, before I can even find the vertical asymptote, you're probably looking at this like, what the heck? I don't even know what to do. Well, first, like anything, you need to get y by itself. So all I'm going to do is a little bit of algebra on the side. So I would pause the video here and just start to get y by itself. All right, so hopefully this is what you are looking at. Y equals x squared minus x minus 2 all over x. Again, all I did was just algebra and I got y alone. All right, so now let's actually start to figure out some things about this graph. So the vertical asymptote we know is always when that denominator is equal to 0. So if I set this denominator equal to 0, I know x is going to equal 0. Next, we got to figure out what the horizontal asymptote is. Since this is top heavy, we know that there is none, meaning there has to be a slant asymptote. Okay, so I am going to do, again, I'm going to do synthetic division here since my denominator has a linear factor where x would equal 0. So I'm just going to do synthetic division here. Okay, So I'll have 1. 0 times 1 is just 0. I'll be left with negative 1 again. Times 0 is just 0. And this is what I'm looking at. All right, so again, you don't care about the remainder. All you care about is what's here. So that slant asymptote is really at y equals x minus 1. So I'm going to go ahead and graph that on my graph, and I'll use black to indicate that. All right, so that's what my slant asymptote looks like. I'm also going to go ahead and draw in my vertical asymptote in red. Okay, so everything looks good so far. Now what we have to do next is figure out what the x and y intercepts are. So again, the x-intercept is going to be when y is 0. Well, the only situation where y is going to be 0 is if we set this numerator equal to 0. Okay, so I'm actually going to factor this because I'm able to. And I actually said earlier we should have factored this, okay? All right, so there are my factors, x minus 2, x plus 1, all over x. So when this numerator is set equal to 0, so when that numerator is set equal to 0, well, our x values are going to be at 2 and negative 1. So let's write that out. Our x values are going to be at 2 and negative 1. And now I'm going to sketch that on my graph. So when x is 2 and when x is negative 1. All right, lastly, we have to figure out what the y-intercept is, and that y-intercept is when x is equal to 0. So let's think about this. So for our y-intercept, that's when x equals 0, and that's for the whole function. So if I plug in a 0 here and a 0 here, I'll be left with a negative 2 on top. But when x is 0 down here, well, now that's undefined. So we don't have a y-intercept. And this should make sense, because if you look at our graph, there's a vertical asymptote at x equaling 0. So when x equals 0, it's not possible for me to cross on the y-intercept at any point. Okay, there is none. So we say there is none. Okay, so now again, you should probably partition your graph. So we have to check out the x-intercepts and the vertical asymptote. So I have negative 1, 0, and 2. All right, so again, here's probably where I would pause the video and now check what those values are going to be in between, whether they're positive or negative. So I'm going to quickly draw those in, and this is something you should double check on your own, but they will be negative, positive, negative, and positive. All right, so now we need to understand what that means with respect to the graph. So as I go from negative infinity to negative 1, all of my values are negative. And as I continue from negative 1 to 0, they're all going to be positive. As I go from 0 to 2, all my values are negative. Got to cross over those intercepts. And as I go from 2 to infinity, they're all positive. Again, you want to be bounding this by the slant asymptotes here, okay? Again, this is dealing with the end behavior, so we are not going to be crossing over. We're dealing with the end pieces. All right, so I hope this video was helpful. Make sure you subscribe to my channel, and I will see you guys tomorrow. Leave me a comment. All right, have a good day. Bye.